Okay, so let's look at this problem. We have a square matrix M that is given to us, and we have to determine if it's a diagonal matrix, scalar matrix, identity matrix, or a non diagonal matrix. Okay, so what we'll do is first we'll go ahead and look at an example of each of these cases, right? So let's start with a diagonal matrix. So how will a diagonal matrix look like? So this is how it will look. So let's say this is the first row. Second row is maybe something like this. Third row is say something like this, right? So this is a 3 cross 3 diagonal matrix. So a diagonal matrix has all the non off diagonal entries, right? So these are all off diagonal entries, meaning entries which are not on the diagonal, all of them should be 0. Okay, as you can see here. So what about scalar matrix? So scalar matrix is, to begin with, it's also a diagonal matrix, but then all the diagonal entries are equal. So it looks something like this. Okay, so a scalar matrix will look something like this. Finally, an identity matrix. What is an identity matrix? It is also a scalar matrix, but then all the diagonal entries are 1. Okay, so now notice this important fact. This is important to note. All identity matrices are scalar. So every identity matrix, or maybe I'll put it this way. So every identity matrix is a scalar matrix. Okay, that's one point. And every scalar matrix is a diagonal matrix. Okay, so the reverse direction doesn't hold here, right? So every diagonal matrix is not a scalar matrix. Likewise, every scalar matrix is not an identity matrix. However, this direction holds, right? Identity matrices are also scalar matrices. Scalar matrices are also diagonal matrices. Okay, so this is something that we have to note. Okay, so to begin with, what we'll do is we'll matrix type, right? That's what we have to write. That's the function name. It accepts the matrix M as argument, and it has to return the matrix type. That's a string. So non diagonal if it is not a diagonal matrix, identity scalar or diagonal, right? If it is one of these three. Okay. Now another important point you have to notice, if you have an identity matrix, you have to return identity as the output, even though it's a diagonal matrix and it's also a scalar matrix, right? So the most particular fact, or how do I put it, the so I don't know how exactly to word this, but then when you have an identity matrix, your the return value should be identity, even though it is also a scalar matrix, it's also a diagonal matrix. Likewise, when you have a scalar matrix like this, okay, your output should be a scalar matrix and not a diagonal, even though a scalar matrix is a diagonal matrix, right? So the most particular fact about a matrix is what has to be returned. Okay, this is kind of, I don't know if this is mentioned in the question properly, but that's something you have to make note of. Okay, so what we'll do first is we'll identify if a matrix is diagonal or not. So what do we have to do? First, we'll have to get hold of the number of rows of the matrix. It's a square matrix, so it's going to be n cross n. Now we iterate through the rows and columns. So for I in range of n and for j in range of n, what do? We look for an off diagonal entry. What is an off diagonal entry? So anything that is not on the main diagonal. So anything that is not on the main diagonal will satisfy this. The indices will satisfy this property. I not equal to j. Okay, if I double equal to j, then that value is on the diagonal. If I not equal to j, that particular element of the matrix is not on the diagonal, so it's an off diagonal entry. Now, if the off diagonal entry happens to be different from 0, if it happens to be non-zero, then surely this cannot be a diagonal matrix, right? So off diagonal entry should be 0 for a diagonal matrix, but if mij is not equal to 0, it cannot be a diagonal matrix, so you can safely return non-diagonal. Okay, so one case is taken care of. Now, the moment you exit out of this loop, if you have not returned non-diagonal, what does it mean? it means that you are dealing with a diagonal matrix. Okay, so here you have to be careful, you can't just directly return diagonal. Okay, because a diagonal matrix could be identity, it could be scalar, or it could be some diagonal matrix which is different from identity or scalar. Okay, so you have to make sure that you check for identity first, and then you check whether it's a scalar matrix. Only if these two are not satisfied are you allowed to return diagonal. Okay, so that's what we'll do now. We'll not delete the diagonal, it will be there at the bottom, that will be the last line of the function. So now we check for identity. So how do we check for identity? We need to get hold of the diagonal elements. Okay, so while you're iterating through the matrix, when you're checking if it's diagonal or not diagonal, store all the diagonal elements in a list. So let's call it diagonal, diag for, so diag will be a list that stores all the diagonal entries. So what are the diagonal entries going to look like? MII. Okay, so I'm just going to append MII. So row index, column index are the same, right? So I append MII. So when I get outside the two loops, what I'll have is the list of diagonal entries in diag. Okay. Now, if all the entries in diag are the same and if they are equal to 1, then it's an identity matrix, right? So how do I check this? If diag is double equal to the list containing 1 replicated n times, then I can return identity. So what do I mean by this multiplication operator along with lists? So if n equal to 3, if I multiply the list containing 1, the singleton list containing 1, and if I multiply that by 3, I get 1 replicated 3 times. Okay, for an n by n matrix, what will this be? This will be 1 replicated n times. Okay, that's exactly what I need to check for, right? When it comes to an identity matrix, I need to see if the value 1 is repeated n times along the diagonal. Okay, so if your function skips this also, meaning if this evaluates to false and you enter, say, come to line number 30 here, what does that mean? It means that it is not an identity matrix, but it is a diagonal matrix. Okay, so far what we have found out is if you manage to come to line 30, it means that it is diagonal but not identity. So can we return diagonal? Not yet, right? We have to check if it is scalar. There is one more possibility remaining. How do we check if it is scalar? So if diag double equal to the first element repeated n times. The first element meaning the first element in the diagonal if repeated n times, right? So that is what diag of 0 into n. So if this diag list is nothing but the first element repeated n times, meaning something like, say, 2 comma 2 comma 2 dot dot dot, right? So that could be a possibility, right? It cannot be 111, right? Because 111 would have already been taken care of when we check for identity. So it won't be something like 111. Okay, so you have to make a note of that, right? So I'll just also comment this part. So we are checking for scalar here, identity here, and we are checking for uh, well, diagonal, not diagonal here, right? So diagonal. Anyway, so if it is a scalar matrix, we are free to return scalar. Okay, finally, if that is also not the case, if that also fails, if that condition here evaluates to false, it means that what you end up with is a diagonal matrix. So you can return diagonal. Notice that when you come to line 35, what does it mean? It is a diagonal matrix that is neither scalar nor identity. Okay, so let's see if this works. Okay, 5 out of 5 private test passed. Okay, so that is the solution to this problem.